Yeah, yeah.
Okay, awesome. Okay, so let's first start with arrays. I want to make sure, like, before we get into the really the nitty gritty of all the data structures and algorithm, we are pretty solid on all these right here. And so I might go a little
Hmm.
bit fast to kind of compress everything. Most of this should be kind of review. So okay. So starting with a array called numbers, we have, let's just say 3, 4, 5. And you'll see me put an annotation for this being non-mutative and
Hmm.
this being mutative. Mutative meaning that it will alter the current data structure. Non-mutative, it won't. It'll just make a
Yeah.
shallow copy. And so to kind of take a brief overview of the methods here. So as you know, filter, it's a classic method. This is a shallow copy um, method that returns you a new array without altering the other one. And so filter essentially filters out anything that you want, right? And so like anything that's
Hmm.
greater, less than, or meets a conditionary, such as, hey, don't return me a number that's equal to 3, then return me that. So an example of that would be new numbers, numbers.filter, num, and as long as it doesn't equal to 3, return me back a new array, which will give me 1, 2, 4, 5. And this is non-mutative. Okay. Find. This is also a for loop. And we'll talk about big O notation on the next one. So this one's going to be O of n. Are you familiar with big O at this moment?
Yeah,
Okay.
yeah. I am somewhat familiar.
Okay. So we'll get to big O on the next one. So on the next meeting, let's book one for reviewing the big O notation on that. And
Hmm.
also, good job on the resume in LinkedIn. I know I added a lot, but now it's like clean. You know, it's just like
Yeah, yeah, yeah,
it's
for
ready to
sure.
go. So find, this is also non-mutative, and this is also O of n. And what this does is it just finds you a particular element through the iteration process. And so if I have one here, do find 3.
Find is the first element, right? So if you have multiple of
Yes,
whatever you're looking for, it'll find the first,
that's
right?
correct. So if I have
Okay.
two threes here, it's gonna exit by returning this one. Yep, exactly.
Yeah.
So I do num and then num. If it's equal to 3, then return me that one. So nice. Slice. Slice is a non-mutative method as well, and this is going to be using the O of 1 constant because you're telling exactly where to chop it off, right? And so this one, if I say, okay, well, return me a portion of a subarray, and the syntax for that is the first argument is where do you want to start the cut, and then where do you want to end, and this is optional. So this one is optional. So as an example, if I do slice or numbers dot slice, if I just put in one index, I'm telling it exactly where to start and where to end. But if I don't put an ending argument, it's just saying, okay, just do it in the entire row after that. So start from 0, 1, 2, and then cut it and return me this portion right here. If I do put a ending index of, like, let's say 3, okay, so just return me this right here. The ending index is not inclusive, meaning if even though this is index position of 3, it's not going to be part of the slice. If you want to include it, you have to go up to 4. So just remember that on that one right here. And so that is
Right.
not inclusive.
But the start is inclusive,
That's
right?
correct. Start is
All right.
inclusive, but end is not.
All right.
And then splice, this is a mutative, so a lot of students get this confused, but splice is mutative. This is a non or mutative process, and this is also going to be n. And this one also takes in a start index. Where do you want to start? Delete count. How many do you want to delete? And also items to add at the starting index. And this can go on, let's say we have x1, items to add, x2, so on and so forth. So where do you want to start? how many do you want to delete from that starting index, and how many items do you want to add as like a third argument or kind of infinite argument, and kind of so forth and so on. And so these two are optional, and you really only need to have this one. And so as an example right here, if I do splice and I say start at 2, remove 1, and then insert a new number called 4. So starting at index 2, insert delete 1. So I'm telling it, okay, delete this 3, and then replace that with being at 4 is what I'm saying here. 2, 1, 4. Does that make sense on that one?
Yeah, that makes sense.
Next up is going to be flat. So flat is going to be non-mutative. And flat, all this does is it just compresses your layers of arrays if you have it. So let's just say that I had an array that looked like array flat. And I had an inner array like this. And if I do flat, it's just going to flatten the array to be one level, so it will look exactly like this. But by default, the flat only removes one layer. And so if it has multiple layers such as this, you'll see a lot of problems where, okay, well, there's multiple layers. If I just pass in nothing in here, it's only going to remove one layer like this. And so how do you get rid of anything that's surpassing one layer? Well, you can pass in an argument of how many layers you want to remove. So if I want to remove 2 layers, then I just need to pass in, okay, I want you to remove 2 inner layers. And so that's where this will get kind of sweeped out and take care of the 2 layers in here. So as an optional argument, you can pass in specifically how many layers to remove there on that one. Okay, and this one is going to be O of n. And so this one, let's kind of go down. Next up, I want to do quickly on includes. So includes, this is going to be a O of n, and this is a non-mutative process. And so this one just returns you a Boolean value, right? So numbers dot includes, hey, do you have this element that I'm looking for? Maybe 4, and it's going to return me true or false. Okay. And so that is kind of the premise of all the methods I want you to be really comfortable with. Filter, especially slice and splice. The assignment I'm going to give you is going to have a lot of that, slice and splice. And so I want to make sure you're getting comfortable with those ones. Now what I want to do is talk about some of the more loops that we wanted to just have you be aware of. So as you know, there's a couple different loops that we can talk about. One of the first ones is on for each. For each, people get confused. If you ever see people do this, where they assign something like data to what do they call it? Numbers. Okay, so this is wrong because when you do a for each, it's a side effect loop, meaning anytime you do a for each, it's not going to return you anything. It's a side effect loop. So it always returns undefined. I always see this in an interview question in the beginning is like, what does for each return? And people are like, oh, it just returns whatever you want it to return. No, it's a side effect loop, meaning it always returns undefined. So it doesn't even make sense to assign it to a variable, right? And so when you do a for each, just be careful assigning it to a variable because it does not return anything at all. It just does what you need to do. And so that could be anything from mutating another array or doing a API call. Usually it's used to do API calls because sometimes you might not want that call back, that promise back. And so for each is just a side effect loop that you want to do something. So you can do num plus 2, and this will alter this array now at that point. Okay. And so this always returns undefined. Okay. So next up, what I want to talk about next is, so as you know, you have 2 other for loops. You got map. This one always returns a new shallow copy of an array. So just like how for each works as a for loop, this one actually just returns you a new copy of an array, whatever that may be, what you want to do with it, and it just returns the same length. So it never changes the size of it, but returns the same length in the array. Okay, and so this one does make sense to assign it. And by the way, this is all O of n, and this is also O of n here. Again, two more I want to talk about, which is going to be the for of. This one is also going to be the same thing as doing something like this, the traditional for loop. Let I of num, and you can do something here for your for loop. And then finally, for loop for let I is equal to 0, I is less than the num dot length. And so it's pretty much what you've been used to doing here. So these are the 4 loops that you should be very familiar with. These 2 is what we're going to use the most in our data structures and algorithms. So definitely keep an eye out for that. Last one is going to be on reduce. Reduce is practically, it can be used for anything. What I mean by that is, if you want to accumulate values in an array, if you want to transform data of an array, if you want to keep track of a count or do some sorting algorithms, you can do all that actually with reduce. What it's defined as, though, is it takes in 3 arguments. One that's called a prev, that's the first argument, the current value of that index, and the index position and the array of the new array that you want to return. Callback, and then the initial value. So this is what it looks like for syntax. So the argument, you can pass in as many as 4. The second argument, you pass in a callback to do what you want to that current element. And then the last one is initial value. Where do you want to start with your with this loop? And so, as an example, if I want to do a sum of it, I can do something like const sum. And if I want to get the sum of this, I'm going to say num.reduce. I'm going to call it total and then current. And if I want to get the total of this array at the top, I just do total of what the current total is and do plus current. And I want to start at 0. So what it's doing is every time it's going to a new array or new element, it's going to take that and add it to the total, go to the next one, have what I have my current total as, and add that new element I'm on, and keep adding on to it, essentially what we're doing here. And so reduce, again, it's going to be really, really powerful to use that going forward. And so I'm going to show you more methods in our practice problem set here. And this is going to also be O of n. Okay. Next, what I want to talk about is on objects. So for objects, inserting a new, if I give you an object here, so if I do object and I do const profile, and I want to add in a preset object with some numbers. There's 2 ways you can add key value pairs or set them, right? So the first way to set new key value pairs is going to be profile.address. Let's say I want to add this new property, and I can type in some address. Or you can use the bracket notation and set the address like this. So this is setting new addresses. Accessing. For accessing, again, you can use profile.address, the dot notation, or you can just do profile, square bracket, address, and access it this way. So these are the 2 only ways you can access an object. And so this is going to be coming in really handy. When it comes to looping, there's only one way to loop on an object, which is to use a for in loop. So for in is to iterate through enumerable properties. So enumerable properties meaning AKA key value pairs. So in a for loop, it's going to look like const prop in profile. Prop is always, you can name this whatever you like. It is always defining the key or the property in that object, which is going to be the definitions of these different properties. Profile is a definition of the actual object itself, which is this representation here. And so if I want to access a value, all I have to do is say, okay, if I want to access Tony, I put in profile, and whatever key I want to pass in, because I'm running this dynamically, I want to pass in the dynamic variable here. I cannot use a dot notation here because dot notation requires specifically for you to pass in the actual property name. I don't have a property name called prop in here, right? So that's why I have to use a bracket. Bracket accepts either the actual property name, or we can take in something like a dynamic variable like I did here. Does that make sense?
Yeah, no, that makes sense.
Okay. And then when it comes to converting to an array, so if I want to convert this object to an array, there's two different ways I want us to get familiar at, which is going to be using the class methods. So converting the keys to an array. So I can do properties, and this will print out all the keys. So say object.keys and pass in the object that you want to print the keys out. And this will print out name and age and maybe address. Converting the values to an array, so same thing. Instead of now doing properties, now this would be values, and do values here. Okay, and this will print out Tony 99, and then some address here, some address. Okay. Now there's two more data structures I want to cover, which is going to be on sets and maps. So I don't know, have you ever touched sets and maps before there, Joseph?
Maybe briefly, but I can't really remember right now.
Okay, so let's talk about that. So sets and maps is another two different data structures I want you to know. Let's first talk about set. A set is just like a sister to an array, but the only thing different is that a set is like array. It only holds unique values, so you cannot have duplicate values. So why would this matter? Well, in a case where you want to have constant read time, when you want to access something on a constant basis, so like when you do like a for loop or something against it, and you want it to run at constant time, that's when you would use a set. And it actually looks something like this. Again, it looks like an array, except that the outer, it's not a square bracket, rather it's a curly braces. And you're gonna have numbers, or you can have other objects in here. And it looks exactly like this, where it just holds unique values, okay? And you use it to, for performance reasons. So if you ever get stuck in using a double for loop, either you're gonna use a map or set to actually reduce that to a constant read time, okay? So that's kind of the primary purpose of it, is that if you ever get stuck of trying to increase your performance on your code, especially in the interview setting where they're like, oh, can you make this in constant read time? Then they're signaling to you to use a map or a set. And so a set is a sister to an array, meaning that it's just holding values here. And so the methods I'm going to show you is creating a new set. So how do you do that? You just set const new set, and you just say new set. That's it. So this will create an empty set for you.
Mm-hmm.
Adding an item. So when you're adding a new item, all you do is take the new set, and the method for that is going to be add, and just pass in the value of whatever you want to add in. So you can say hi, or you can also do add in a number. But keep in mind, if you try to add in another duplicate, such as hi again at the bottom, what's going to happen is it's not going to error out or anything. It's just going to replace what you have in the current resource. If I said hi here, it's going to be like, oh, I already have this, so I'm just going to go ahead and replace that again here. So it's not going to add a new high here like this. So keep that in mind on that.
Mm-hmm.
Part of the reason why it does that is because a set, the whole purpose of it is that only holds unique values, so that way you're reading things in constant time rather than linear time compared to an array. And so that's kind of the advantage there, is that when you get to the point where you're trying to use like checking if a value exists, well, if you look here, for an array compared to array, where if you want to check if a value exists, you would use .find or you would use .includes, right? But both of these are running on linear time. Does that make sense? So in an array, this both works on a linear time. And so the advantage here is in a set, you can actually find and kind of look for an element in constant time. And so for a set to do something similar like this, you would use a method called, I'm going to write it here, so I'm going to say new set dot has, and you pass in the element that you're looking for. Let's just say that you are wanting to look for, let's say this 200. That has, because everything's unique, it knows what the values exist within this set. It's going to read in constant time. So that's where you have an advantage there, is the fact that when you want to check if a value exists, then a set is way, way better, because now that you're going from linear time complexity to the best time complexity of 1, meaning it's not going to have to go through and iterate through every single one. It's going to know exactly if it has it or not because of the unique value aspect. And so because of that, when you're doing something like where, let's say you have a for loop, you're iterating through some kind of array, so let i's of nums, so we're iterating through this array, and you're comparing it to like a set inside. So let's just say that instead of I had a set here, I would make a new array, and I want to compare this first array, let's just say, to this array if it wasn't a set, and I want to compare if all the numbers match up, right? So you can do, you know, like on the second array, so const second array dot find of nums of I, but this becomes n squared because, well, this is a n, this is an n, and that becomes n squared because now you're doing twice the amount of work in one go. And so that becomes a very performance laggard, right? And so what's a solution? So you're going to get to this situation a lot in LeetCode or wherever you're doing this. An alternative is, okay, well, I can convert this into a array, the second array, to a set. And if I change that to a set now, and I'm going to go ahead and copy this down here, I can do new set and do dot has. Now I converted this to being O1, and what does that become? Well, by the kind of the rules of big O notation, that just becomes 1 times n, which is going to reduce down to just n. And so now you just completely reduced your time complexity just from going from n squared to just n. So way bigger performance difference here now, because this set is now a constant time feed instead of a quadratic. Does that make sense?
Yeah, so for set, are you allowed to, let's say like you said in this example, let's say you already have a second array, right? It's an array. How do you convert that to a set? Do you just, can you feed in an array into set and it'll automatically?
Exactly. So let's just, exactly right. So let's just say I had this second array of 1, 2, 3, 4, 5, and I want to compare the numbers of this one with this collection. What's nice about sets is that it will consume initially. So if you don't want to And by the way, you can only manually add one item at a time with this method. So if you're like, okay, how can I make this where I'm just taking this array and convert that to a set? All I do is just pass in, oops, I made this second array. And then now I'm gonna get something like this, where I get 1, 2, 3, 4, 5. So really easy to do.
Right. And then it'll weed out like if there are any duplicates.
Yes, that's correct. So if you already have duplicates, it will weed those out, like so. So it will already compress that for you. Yeah, exactly right.
I gotcha. And then there's the time complexity of creating that new set with that array, like O of n as well.
Creating this.
Yeah. So let's say you put in that second array and there's like a duplicate, like there's a time complexity of creating that new set, like O of n, or is it something different?
Yeah. So creating this new new data set is actually going to be constant. So all it does is just under the hood, the class set is based on JavaScript's object-oriented programming, which we'll get to as well. It converts that into a set using constant time because it only looks at the first number and then it just skips over to the next new value. And so that's part of the JavaScript built-in classes for set, is that it does that by not looking at every single number, but it skips through the ones that it doesn't need to know. And so that's why it can forego being linear time on that. Does that make sense on that one?
That kind of makes sense.
Okay, I can explain a little bit more here on this. So again, when it comes to creating arrays and you're trying to transform this into a set, what happens is it's not linear time, because if it's linear time, it's going to actually go through and check every single number to do that. But under the hood, and I'll kind of share the code of what this looks like under the hood for JavaScript. What it does is it has what's called a radix sorting algorithm, where it will skip over a repeated value under the hood of how this JavaScript script, the set was built, and it will skip over the ones that it doesn't look for. And the ones that it skips for, that becomes a reduction to log of n now. But how does it go to constant time? Well, essentially, when you have repeated values here, anytime it has a counter, and anytime it sees any repeated values, it will just pop that off. So it uses some of the stacks and queues that we are going to be talking about under the hood. But one thing just to have the biggest worry about, though, is just knowing this isn't the biggest weight that you're going to add, but it's rather going to be the methods I want you to focus on. And so the methods, as long as you know like what the time complexity of these methods do, that's all you should be worried about in terms of the biggest detrimental performance factor here. And so that kind of goes the same way with now for maps. So what is a map? So this is also called, what is going on? There we go. Okay. And let's do a map to kind of finish this off. So map. So a map is a sister to an object. So think of this as a sister to object. Same thing like a set. It only holds unique key value pairs. So this looks like something like this. So just to show you here what this looks like. Oh my God, did I just delete all that? Oh, there we go. Okay. So just to show you what a map looks like, if I do const new map, here, and then I want to do new map dot set, and the first argument it takes in is a key, just like an object. I'm going to say name, and then Tony. So that's what it looks like. It literally looks like an object, but it just has like a arrow to kind of indicate what the values are. And so if I want to add a new one here now, if I do age, and I do like 99 or 88, this is what it looks like. So it kind of looks like an object, but it's really not, in the fact that you're using an arrow instead of a colon, I guess. And so what's the difference here? Well, if I, oh my God, some technical difficulties here. Okay, let's go here. So instantiating a new map. So we'll say here, this returns us something like this, name, and then an arrow to point to a value, age, point to a value. Again, just like a set, it only holds unique key value pairs. If it already has a identical key value pair, it's gonna remove the duplicate. So same logic applies here, but now you're dealing with key value pairs in here. And so instantiating or creating a map, you do const new map, like that. Okay. When it comes to adding new key value pairs, you do const, or I should say new map dot set, and you put in whatever new key value pairs you want to add. So let's just say I want to add in Tony. Okay. If you want to check if a value exists, same thing applies. Check if a value exists. That would be new map dot has. Do you have the value Tony? And if it does, it's going to return us true or false. And this is reading in constant time. So this is in constant time. Now to retrieve a value, that would be retrieve a value. This is going to be, what is it? Get, so new map dot get. And let's just say I want to get the name property value. So I just say, okay, give me the value of name property. So this one's going to return me Tony here. Okay. Does that make sense so far on this one?
Yeah, it makes sense.
Okay.
But for maps, I think is it specifically going to have unique key value pairs? So you could have like technically the same key but have different values associated?
Yes. So as long as the key and the value are different, that's fine. But if you have the same key and value pair, let's say you had two words like name Tony, name Sam, that's fine. But if you have one that says like name Tony, then it's going to remove that duplicate in there.
I gotcha.
Yep. But I generally would say that it's a bad idea to set a property as the same name though, because you're going to run into trouble where you're going to get unintended consequences of like not finding the one that you're looking for, right? So you don't know if you're going to return that first one or the second one in there, if that makes sense.
Right.
So, and give me 1 second here. Let me message Kevin. I think he's got a meeting. Okay, while he's getting ready, let's finish this off here. So when it comes to looping, for sets and maps, the only loop that you can use for a map or a set is a for each. And that's because that's just the way that the JavaScript was built using the maps and sets. So if I look up the documentation for this, you will see, so set JavaScript here. And I'm going to give you some reading materials as well. So these are all the different methods, right? The only loop that you can use on a set and a map is going to be for each, okay? And so if you're trying to iterate when it comes to the sets and maps, you can only use a for each in here, okay? And so the for each is the same thing that you have used in the past, where you're passing in a callback function and you're iterating through it. And so just keep that in mind, that you can only use a for each to loop through a set and a map. So again, sets and maps, for each is a for loop. For an object, it's a for in. For an array, you can use for each, you can use map, filter, find, reduce, for of. Those are the 6 different for loops you can use for an array. So I want to make sure that we're kind of like very, very solid on those as we go through the process. Okay. Does that make sense?
Yeah, that makes sense.
Okay. So that being said, I want to show you here the assignment that I want to give you. So every time now we have a meeting, Joseph, we're gonna have these lessons, and I'll be giving you an assignment to kind of help you kind of, okay, did you understand the lessons that we did today? And it's gonna be kind of challenging sometimes where I'm gonna give you a problem where like, oh, how do I do this again? So you have a bunch of resources to kind of look at. So one, you can look at the recordings I would be uploading to you. I'll be sending this to your email every single time. Two, going forward, you're going to see more visual diagrams. I'm going to start drawing out, okay, so this is how you solve these data structures like that way. Starting with next week or the next meeting, set the next meeting to be for big O notation. And then third, I'll be pushing up all my notes to you so that way you can reference those. And then fourth, what was I talking about? Yeah, you could ask for help. So these assignments are going to be challenging, but it's going to help you grow to kind of understand, do you actually understand what we talked about, and kind of solidify your knowledge there. Does that make sense?
Yeah, that makes sense.
Okay, so I want to show you the assignment itself of what you're walking into. So just complete this whenever, but I would like you to complete this before you set up your next meeting. So have it complete so that way you can get feedback from me, and then go ahead and schedule the next meeting. And so let me bring up that. Okay. So this is all the JavaScript fundamentals I am going to expect to have you know how to do before we start moving on to the lead code questions. So this has to be 100% in order for it to like get smoothed right away into the data structures and algorithms portion. Okay, and so it's not that bad. It's some of it is get practice, which I give you some instructions how to do that. It's talking about practicing on using the new set and maps, using the for loop, given the data structure, and all the array and object methods that we talked about, and on some of the ways that you would classify some falsy and truthy values here. Okay, and one thing I forgot to show you here is on the object. Where's the object here? Yeah, right here. For of. Okay. One thing that's cool about this for of loop is if I have an object or a array called numbers, and I just had a bunch of objects listed here. So I say num1. I'd be surprised if someone can live that long, but so let's just say that I want to print and do something with each of these properties. So for of, what's nice about this compared to the regular for statement is if I have a for statement, I can, if I know I'm iterating through every single iterable object in here, I can do what's called destructuring, right? I don't know if I showed you this before, but you can actually destructure out and pull out the keys like this. And actually now I can print out the values. So I can say console.log num and h, compared to if I do something like this, for const obj of numbers And if I want to console log the actual values here, 499, I have to do obj.num and then obj.h. So this is just so much easier because now I can do this because every single item I'm iterating through at this point is an iterable object. And an object, I can do destructuring just like how you did in React. And now just pull out the keys that I only care about and print out the values there. Okay. And so this is a really powerful method of destructuring. Another way I can show you about destructuring is if I give you some really complicated objects such as difficult here. And let's just say this had a profile property and this also referenced another, I had a name, Tony, age of 88, favorite movies, let's say. And this was an array of movies, so I'll just say Spider-Man, Batman, oh god, I'm like spacing out here. So, and
okay.
Let's just say I had another one where I called it addresses or something. Let's just say another object. So we just do this, and this references another, let's say, I'm trying to think of, this is the hard part. I'm trying to think of a name, but I can't. This is the hardest part.
It's all good.
Yeah, so schools, schools, colleges, and let's just say this one is like Duke or something, and this references something like that. So let's say this one's a price of 200. So this is a pretty nested object, right? Whenever you get something like this, especially when you become a real software engineer and you have to work with this complex data, don't do this. Don't ever, if I want to get to, like, let's say, I want to get to name. Okay, one way is doing difficult.profile.name, and yes, I get Tony, like this. Would you agree with that? That's going to get you name.
Mm-hmm. Yeah.
Or also you can do difficult.schools.colleges.duke.price, and then I'm going to get price, right? Let's see how long this is. It's so lengthy. What you could do is just destructure this. So let's just say that you are working with a payload that's really complicated, and you're doing this to set some values so that way you return to the user. Instead of that, destructure it so that way you do something like this. Const destructure. Now you can destructure out all the properties. Well, I'm going to destructure out profile. And from here, I want to now just get name. And this is going to return me the value. And then let's say I want age. So I just do age. That's all I want. And then on the next object, I want to get out the price. So I do school. Colleges. And Duke. And from here, give me the price. And so now if I do console.log here, I am going to get 200 back. So just to show you here, I'm going to go ahead and comment this out. Let's paste this in const. There we go. Let's put this in the console log and see what we get. So I have here the actual object, and let's just say we're working with this complex payload. I am using, and I forgot, I gotta set this equal to the object itself, which I call it difficult. And let's see if this prints out price. Boom, there you go. See that? This is the way that a lot of professionals, and how a lot of times if you work with a really nested object, that's how you extract data, is through this kind of methodology of destructuring. And so this is a way to do that when it comes to dealing with very nested objects through destructuring. So just only pull out what you care about. In here, I just cared about getting name. And so if I want to get that, I can just now do console.log name. There you go, Tony. Easy. I don't have to do difficult dot name, whatever that may be. Go through that
Yeah.
process again and again and again. So always, 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 dry is the formality that you want to follow.